Hi, my name is Krishamad Balingtan, grade 10 from Golden College. Today, I am going to discuss the Continental Drift Theory and the Seafloor Spreading Theory. Look closely to the map. Doesn't the east coast of South America fit exactly against the west coast of Africa? As if they had once been joined? In year 1912, Alfred Wegener published a theory to explain why the Earth looked like a huge jigsaw puzzle. He believed the continents once joined, forming a supercontinent that called Pangaea, meaning all Earth. As a result of movement of the supercontinent, Pangaea split into two superland masses, namely Laurasia and Gondwana. Laurasia makes up the northern continents of today, consists of Europe, North America, and Asia. Gondwana makes up the southern continents of today, consists of South America, Antarctica, Australia, India, and Africa. There are evidence of continental drift theory. Number 1. Fossil relevance. There are various examples of fossils found on separate continents in no other regions. This indicates that these continents had to be once joined together because the extensive ocean between these land masses act as a type of barrier for fossil transfer. Number 2. Information from climate. It is suspected that the northern part of Pangaea was covered in large tropical rainforest, while the southern hemisphere was covered in glaciers. Number 3. The perfect fitting of continents. Wegener also provided evidence of continental drift by looking at the physical shape of continental coastlines. The shape of continental coastlines visibly match of like pieces of the puzzle. Wegener did not find evidence to explain the movement of the continent, and his theory was rejected. Seafloor spreading is a geologic process in which tectonic plates, large slabs of Earth's lithosphere, split apart from each other. It was proposed by an American geophysicist, Harry H. Hess, in 1960. To understand more the process, I made the seafloor spreading model. The different colors represent how rock changes over the years. The middle slit represent the mid-ocean ridge. It is the region where new oceanic crust is created. The formation of the new crust is due to the rising of the molten material called magma. When the molten magma reaches the oceanic crust, it cools and pushes away the existing rocks from the ridge equality in both directions. A younger oceanic crust is then formed, causing the spread of the ocean floor. As the rock moves, it becomes colder and denser until it reaches an ocean trench or continuous spreading. So what happens to all the rocks that were pushed away from the ridge? There are two possible occurrences. It can either be subducted into the ocean deep trench or continue to spread across the ocean until it reaches a coast. Subduction is the slanting and downward movement of the edge of the crustal plate into the mantle beneath another plate. It occurs when an incredibly dense ocean crust meets a deep ocean trench. Once the subduction occurs, a melting happens due to a tremendous friction. The magma could either go back into the mantle for another convection currents, leading again to another seafloor spreading. Or number 2, could burst through a crack in the continental crust and creates a volcano. There are three important evidences for seafloor spreading. First is the evidence from ocean material. Rocks shaped like pillows only form when molten material hardens quickly after erupting underwater. As the molten material hardens, magnetic minerals inside the rock line up in the direction of Earth's magnetic poles. This forms unseen magnetic stripes. The magnetic poles reverse themselves. The stripes are mirror images on each side of a mid-ocean ridge. Youngest rocks found near mid-ocean. Oldest rocks found far away from mid-ocean ridge.